In this example, we're going to be looking at an oblique impact between two pool balls of equal mass. We will look at the impact in terms of conservation of momentum, although if you assume the collision were perfectly elastic, you could also look at it in terms of conservation of energy. We will be assuming the collision is not perfectly elastic. The two governing equations for this problem are the sum of the external forces equals the change in linear momentum, and the coefficient of restitution is equal to v separation over v approach. The coefficient of restitution only applies to the axis the impact occurs on, which we have defined as being the y-axis. Right before the impact, the cue ball approaches at an initial velocity we will call VA1, and VA1 makes an angle beta with the y-axis. This is an oblique impact rather than a linear impact because VA1 does not line up with the axis of impact.
After the impact, the second ball starts to travel towards the corner pocket at a velocity VB2. In order for this to happen and still conserve momentum, the cue ball has to change direction and take a slight right turn. Since there are no external forces on the system, we can set the change in momentum equal to 0. If we look at the x and y separately, we can find two separate momentum equations. We can also find a third equation using the coefficient of restitution. Using these equations and knowing a little dynamics, you can definitely up your pool game.
Wait, why didn't the cue ball follow the arrow we had drawn previously for VA2? Well, there's one more thing to consider. These pool balls are rolling spheres, not just sliding blocks. That being said, the cue ball also slips while it rolls sometimes because when it is not struck through the center of mass, the pool stick applies a torque to it. When this torque is large enough, the ball can start moving while also be slipping while it's moving. This is what happens in this example. The pool player we recorded knows all this and hits the cue ball in a way where it will spin into a better position in order to better set up his next shot. I mention this because at some point after the cue ball heads in the direction we have shown at velocity VA2, it stops slipping and subsequently proceeds to change direction again, and it rolls in a different direction.